Good afternoon, everyone. This is Jay Parikh from CAMP. CAMP is a research arm of OEMs working together on a pre-competitive area in the particularly vehicle-to-vehicle and vehicle-to-infrastructure communications and for, in collaboration with and cooperative agreement with the Federal Highway. So moving forward, what I'll talk about today is you heard Steve talk about the message encryption and authenticity of the message, but that SCMS does not provide you verification of the data or the content in the message. So I'm going to talk about the content part of the message and how to verify that in this project. So to this end, CAMP has developed a document called SPaT map verification, and I'll go over this content of this document. Just to start with, this project is in a cooperative agreement with the Federal Highway as a part of the disclaimer. And all the findings or the work that we've been presenting here is of CAMP opinions and the output of the CAMP's work and not from the US DOT. So a consortia at CAMP called Vehicle to Infrastructure Consortia consisting of 9 OEMs, and so this project was conducted under the auspices of those 9 members. What I'll go over today is what the red light violation application means and what a system architecture. The verification process that we have developed for targeting the red light violation warning from the OEM's perspective, because you can be transmitting information that's been specified within the SAE standards, but we realize that some of this information is optional. However, the application requires more than what's been defined within that optional requirements or optional data elements. So I will go over that also. So this is again from the point of view of having it from the red light violation application. We talk about system architecture briefly, what has been put together from the vehicle side of it as well as from the RSU side of it during our testing and such. What are the intersection implementation requirements, and followed by that intersection implementation verification steps, goals, objectives, method level and application level, and finally the structure of the document that defines how it's been laid out. Okay. So with that, this is just an overview of what the red light violation warning application does. It warns the driver of an equipped vehicle approaching a signalized intersection when a potential of running a red light violation. So when that potential exists, this is what the application is warning the driver of red light violation. And it requires specific pieces of information coming from RSU, which is of course the SPaT information and map information, and optionally but recommended GPS RTCM correction information. The application level is on a lane-based information, meaning that vehicle needs to understand what lane it is on and associate the correct information with the lane and the phase to generate a threat for a red light violation warning. So this is just an architecture overview of how things are connected together in terms of the RSU and information that needs to be received by the vehicle, and how the vehicle is processing that information. That also includes the interface with the CAN bus, so that it has vehicle dynamics information along with it for the threat assessment. So to start with, what are the requirements in terms from the infrastructure side of it? So of course the RSU specification includes US DOT DSRC specification document 4.1, which is I think in the progress of also going to 4.2. Message specification as per the SPaT and map message J2735 2016 version of the standards. And you already heard Steve talk about SCMS and other requirements for the security purpose. So after you implement this RSU at an intersection, what are the things that we need to address or understand for verification purpose? So one is to correct, to make sure the operation is correct and needs to be verified. and compliance with the specifications, and also accuracy of the data element, which is very important element here. If that has been verified, then it can be utilized nationwide, primarily because the application that runs on the vehicle side of it can be anywhere nationwide, and they would like to have, meaning the OEM would like to have all those information transmitted is compatible for the application that's been deployed by the OEMs. The document addresses those in a 3 different levels. One is a system level, which is comprising of the systemic requirements such as the standards for RSU and message and other things, SCMS and such. The second level of verification is at message level to confirm that the message transmitted is as per the standards, and content is also as per the standard. And third, which is very important element, though it is considered as optional, but from the receiver point of view, which is application level, to make sure that data element and the content of the data element are correct, so the application behaves as intended. So the objective here is to develop this pattern map process to help deployers and deployment activities, that's initiatives through the SPaT challenge. So that's where the document was put together. The scope is to intersection. So using the steps and process, we can identify the application, identify or at least go through the process to see if the intersection is transmitting as per the defined requirements, and the outcome will be to validate a process. So this is what we have developed as part of this exercise, and we've been doing this testing along with Michigan DOT, and what we learned through our process, we defined the document. So the version of the document that is out today is version 1.2, which is from the NOCO's website that you can download. So the document comprises of 5 major elements, which is the V2I applications and system architecture, minimum performance requirement from the application's point of view, which is a SPaT map and a message transmission requirements, followed by verification of an installation, which is a system level, message level, and application level, validation of and the steps that we went through and what we discovered during the process when we did verification of several intersections, and what we discovered out of that in our observations. And last but not least, here we are added is also based on the conversation we are having with the IOOs regarding what are the needs for RTCM or GPS correction, and that section talks about the needs and requirements for RTCM corrections for the transmission part of message also. So this is quickly go over the OBU. What we have is an OBU that receives DSRC message and a GPS receiver, including the GPS receiver, and has an HMI DVI that allows us to see how the application is behaving, what message information is received, how the signal phase information is associated with a specific lane information and so forth. And RSU, of course, that's US DOT, DSRC, RSU standards, and signal controller 1202 standards, and optionally we would like to also receive RTCM or GPS correction information along with it. So the message transmission requirements talk about what rate the message needs to be transmitted. So MAP is transmitted at 1 Hertz and the SPaT at 10 Hertz, and of course RTCM 1001 and 1005, they are at 2 Hertz and 5 Hertz. That's what the requirements. The document outlines additionally talks about the required versus optional message, and I'll show you from the application point of view what are the message requirements that needs to be transmitted, or data elements needs to be transmitted, because the J2735 may have identified some of the data elements as optional. However, they are important elements for the application's point of view. The other important part that we learned through this exercise is also the interpretation of the data elements and their use. There has been a scenario where it has been interpreted incorrectly at some of the intersections, and that was identified for the application's requirements point of view. Timing requirements is also accuracy is very important. What we learned over the period of time during this our exercise and testing is that the RSU needs to be synchronized GPS time, because that timing is very important for the OBU synchronization for the OBU timing. So the time remaining for the next phase is consistent and correct information coming out from the RSU that is received by the vehicle. And mapping accuracy requirements also part of this document that we have listed in this requirement part. So from a system level requirement, the reason for having system level requirement is to ensure that system is built according to the standards defined by US DOT, RSU specs, NTCRP, and SCMS requirement. Now the document does not go into detail about this because there are links that provide you the detail for those specifications. The message level requirement ensures the message transmitted by RSU are as per the J2735 2016 version of it. That's what we have been addressing, and that's what we've been using it in here. And the proper encoding in the UPER encoding is done, and data elements are formatted according to that requirement. We have learned and experienced that in some messages that we received during our testing, they were in 2016 version of it, but some of the data elements were still being transmitted in 2015 version of the format. So those inconsistencies was observed in some of our testing also. And of course, the data content is validated for correctness and its accuracy. The application level then provides you a more detailed information about the transmitted information is correct or not. For example, a lane that indicating that it's red, is that exactly what the SPaT is telling us at a given time? And also the time remaining for the next phase is also indicated correctly, and at the same instance, the signal light controller is also changing the phase information. So these are the verifications are very important for the application to behave correctly. So this diagram talks about what are the steps that one needs to go through in order for the verification part of it. And again, you start out with defining the map of an intersection, which can be done either manually or automatically as step number one, and provide the information, the valid information about the reference point, the number of lanes, node points, and so forth, which are valid information and correct information for that specific intersection that you are, for the map that you are transmitting. Today, there are no specific standards defined how that information is loaded into an RSU. Depending upon a vendor, it could be either in XML format or text data format or such. And so just depending upon who you are dealing with, you may have different requirements. So that's something is also missing within this whole context of how do you actually populate the RSU with the information or the message. So that needs to be carefully addressed also. Interface with signal controller, and so broadcasting SPaT information that gets the information from the signal controller, and that is again matches with the map that has been defined and the lane level information that's been defined. So from a verification point of view, one needs to have a tool that can receive that information and compare against what was actually inputted from the step one and so forth. So the key that share my screen, okay. Oh, I lost connection.
I'm not sure. For some reason, the slides like stopped sharing. I'm just loading it right now.
Okay.
Can you see it now?
I can see it my side.
Okay, it should be good.
Okay.
You can go.
All right.
We can see it as well.
All right. So what I was saying that the key element that we discovered during our testing and following through this process is that what is been interpreted by RSU from the information coming out from the SPaT controller and what is actually transmitted were two different things, and that is something very important element because your signal phase information is very critical for the application to behave correctly and don't give a false warning to the driver and or not give a warning to the driver, and it can be very unsafe. So this diagrams explains those steps and what are the elements that needs to be actually verified in this entirety. We'll quickly go over what are the attributes that are used for map and SPaT, and this is just a small list, but let me just jump into this list. This is where we talk about the SPaT data element, and if you notice, the three data elements are defined as optional in case of in the standards J2735. However, those are required elements from the application's perspective, so application point of view. We also have experience with different installations that in some installations those are treated as optional and are not transmitted by the vendor, but from the application's point of view they are required data elements. Similarly for the map, as you can see, 6 data elements are defined as optional in the standards. However, from the application point of view, it is required to be transmitted. One of the element is called the lane level mapping for the intersection. Now, the application would have a very hard time to provide a correct warning to the driver if the lane level information is not transmitted. So that becomes a critical element, data element that needs to be received by the system. Just go over quickly on the couple of intersections that we have tested and what our findings were out of that. First, we found out that one of the intersections was transmitting information which was the 2015 version of it instead of 2016. We also learned that in one case, instead of transmitting the information about the current phase of the signal, it was transmitting information about the pedestrian crossing phase. So that was misinterpreted by the RSU vendor, and it was corrected. We also found it that in the same intersection, from the map point of view, out of 4 lanes that are ingress to the intersection, only 2 were mapped. So when we drive our vehicle to the other 2 lanes, we never see any warning or anything coming up, primarily because those lanes were not mapped. But however, it was transmitting the part of the map. So these are the kind of anomalies that we discovered. We found a similar thing on another applications here that is transmitting 2016 version of it. However, the map was indicating that these are the egress lane and not ingress lane, which is what required for an application. So these are the little things, but they can really throw off the behavior of the applications. So that's what our observations were. And these are the kind of lessons learned we have identified in our document. I'll quickly go over the RTCM or positioning requirements that is a very important or critical element for the vehicle to know which lane it is on. And that is very important because a lane needs to be associated with the phase information for a specific warning related to that lane on which the vehicle is traveling. I'll go here. So there are several, the document identifies, and I'm not going to go over the detail about these things, but there are several errors that are generated from the satellite under different conditions. And primarily it boils down to what it says in this table is that depending upon what kind of error it is, the positioning error can be as much as plus minus 2.5 meters in some cases, and as low as 0.5 meter. So this table describes what are the different errors that can contribute into the positioning error, and the cumulative error could be much higher than 2.5 meters. So So we talk about RTCM, and RTCM is one way to transmit those correction information which is standardized, and this section briefly goes over the RTCM part of it. So I'm going to jump to what are the different versions of RTCM is done. Now from applications point of view, we require that RTCM version 3.0 is used for transmitting this information. So again, by transmitting the different versions may have different implications on the receiver side of it and the positioning accuracy side of it, which can impact the behavior of the applications. So what I'll go over it here. So the big question is that, do we need a RTCM correction for every intersection or everywhere we install the RSUs? Well, whatever our work, that research work that's done at CAMP as well as at other literature studies indicate that what we have done is identify those intersections in three different classes. One is, let's say you have an intersection that is an open sky, clear visibility satellite intersection. In this case, and your complexity of the intersection map and SPaT is not very complex, very straightforward, which may not have many turn pockets or just a straight line, and they're all very nicely laid out. In such case, even if you have a RTCM correction, the benefit that you get may not be does not add as much benefit to the positioning corrections in the vehicle side of it. On the other hand, if you were to go to an intersection such as in a downtown where the high-rise buildings are there and such, even if you add intersection with RTCM correction, if the vehicles are not able to see the GPS satellites, it cannot apply the correction, so it doesn't help either in such case. However, what we are recommending is that if an intersection is complex, even if you are with a clear sky visibility, but intersection is complex, which is a complex SPaT and map phase informations and position, that's where the position correction will be very helpful, because that will allow the application to behave as intended, and specifically to have a much better lane level accuracy, so the warning can be generated accordingly. So with that, what this table describes that benefits under different conditions that you can get when an intersection is equipped with a hardware, in which case you can have open sky conditions or obstructed view conditions. But under the open sky conditions, with the most complex intersection layout and the SPaT information, that configuration gets the most benefit with the RTCM correction. That's my talk and my presentation on this document that's been published, and it's at NOFO website.